Assalamualaikum warahmatullahi wabarakatuh. It's good to see all of you again, my students. Okay, so this is the beginning of the topic of chapter 5. Okay, as you see on the screen here now, it's divided into 4 parts. First is vectors in 3 dimensions. Vectors is called scalar product, vector product, and application of vectors in geometry. Okay, so without wasting so much time, let's continue. So we begin with the first part of the lecture here, vectors in 3 dimensions. Okay, so please refer to your lecture notes. So in this part, we're going to look at the types of vectors, the magnitude, perform addition, subtraction, and scalar multiplication, and also find the direction of the cosine. Okay, so let's take a look at the first part here, definition. A scalar, we call a scalar is a quantity that has only magnitude. Okay, as you see an example here, and vector is a quantity that has both magnitude and direction. Meaning, direction here is we could tell us where is the the vector moving on to the left, right, or any from one point to another point. Okay, so as you see here is an example here: velocity, force, weight, and momentum. So geometrically, vectors can be represented by a directed line segment. As you see here now, that we have the beginning, the starting point from A to one point of destination here, from tail, the initial point, to the head of terminal point. So from A, look at direction of head of the direction here. So we can put this as a direction. We call the vectors of A, B. Okay. Okay, a vector can be written as a vector of AB, or we can represent with a single vectors notation of U here with a curly sign from A to B, or we can recall with this a label here. So magnitude, also called norm, denoted as a vectors of AB, or we call make the magnitude as we call a U here. For this one, we call this as so we call the sign of absolute values of the vectors of AB, or absolute values of what we call the vectors of U here is the length of the line of AB. And direction, the arrowhead on the line of AB, as you see here, from A to B. This shows the direction from A to B here. Okay, type of vectors, zero vector, null. A vector which has a zero magnitude represented by vectors of O, we curly sign of this, and vectors of A. Unit vector, a vector which has a magnitude of 1, denoted as a unit vector of A, equal to vectors of A divided by absolute values, or the distance of the vectors of A here. And position vector, any vector that starts from the origin of 0. OA is known as the position vector of the point A relative to 0. Means that if this, for example, 3 dimension of vectors here, x, y, and z, so this is the origin point of 0, 0, 0 to any point of A here. Okay, so from 0, 0, 0 to the point of A, so OA is the position vector. Okay, OA is a position vector. A free vector which is not has a fixed position. Okay, equal vectors. Look at this one here now. Two vectors A and B are equal if both have the same magnitude and the same direction. So we need to consider two things here. First, the magnitude and the direction. Okay. P and Q, look at that, we call from point of 1 to another point here. It looks, we call the same. And also the direction, direction are also equal here. But then for P, R, and S, P and R, you can see that direction to one here and one to another, a different direction. P and S might be same magnitude, but then they have a different direction. Okay, 1, 2. Okay, you see this triangle. We call direction here, and one opposite direction of the P, opposite. So P, R, and S are not equal at all. Okay, negative vectors of A has the same magnitude as A, but then oppositely directed. Okay, so you can see here now, A and A has the same magnitude, but then the direction is opposite. We call different, oppositely directed. Okay. And operation of vectors, addition. So then the vectors of A and the vectors of B, if we combine here now, it gives us a vectors of A plus B equal to a vectors of AB. Okay, using the triangle law. Okay, now, why do we have two different vectors here? A plus B, then we are referring to this, the vectors from the point here and the vectors of A plus a vector of B, okay, to achieve at this point, okay, at this coordinate. But then, look at this one here now, from this point, then you come, first we using the root of vectors of B and then plus with the vectors of A. So that's why they come up with a different, we call addition of two vectors. Even though it gives us the same direction, the same destination last point here, but then because we're using a different root, then it gives us a different addition of vectors. Okay, using a parallelogram, notice that A plus B equal to B plus A. If A is not 0, the multiplication of a vectors by scalar k is denoted by Ka. Okay, so this one single vectors of A. So look at this one here now. The magnitude of these vectors is double from the vectors of the origin of A. So it's double or 2 times the vectors of A, and then this is also double the magnitude of these vectors, but then look at the direction here now. Okay, the direction is oppositely directed or different, and here now, this that we call the green line here is half of the vectors of A. If this magnitude is 4, then this is 2, half of the magnitude of the A. So the distance of this is half of the distance of this. Okay, so here now, if k greater than 0, then k multiplied with A is parallel to the we call with the vectors of A, and Ka has as we call the absolute values of Ka equal to K with the vectors of A here, distance. K multiplied with the vectors of A has the same direction of the vectors of A itself. Okay. Okay, I'm not going to explain all one by one, which I think that there's nothing much we're going to discuss this. It's very directed. Now, when given to us the vectors in 3 dimensions, look at the definition here. This is the point of origin 0, 0, 0. Okay, with a vector with coordinate of 0, 0, and 0. So then, from O to this point of A, we denote as we call a vectors of A here. Okay, look at this one here now. O to A, from O to A equal to OP, from O to P here. From O to P plus with P to Q and Q to A. Okay, even though it took such a long distance, okay, to reach this point of A, but then because in vectors we need to consider 2 things. The first is the magnitude and direction. So even though we take the 3 different routes from O to P, P to Q, and Q to A, but because we reach at the same point of destination here, so we simplify this as an equal to the vectors of OA. Okay. So from any vectors of A and B, and for any scalar of K, then the addition and subtraction of vectors of A plus with a vector of B. So we adding the magnitude of the same direction of I with an I, then we get A1 plus B1 for I, then A2 with B2, addition of the magnitude of A and B for J, and also A3 with B3 for K. Then subtraction of 2 vectors, opposite of this, with we only operate between the magnitude of the I with an I, J with a J, and K with K. Okay, as you see on the screen here now. Multiplication of vector by a scalar. So vectors of A we multiply with a K, and also let's say if I given here the vectors of A equal to 3I minus 2J plus K, so then 2 times A means that is 2 multiplied with 3I minus 2J plus K. So 2 times 3 equal to 6I. 2 times negative 2 equal to minus 4J. 2 times 1 equal to 2K. Okay, that's example here. And the magnitude of a vector here, absolute values with the distance of this, A square plus BA2 square plus A3 square. And unit vectors of the vectors of A equal to the vectors of A itself divided by the distance or absolute values of the vectors of A. So as you see on the screen here now, the magnitude of A, where I, J, and K divided by the distance of the vectors of A itself. And direction cosine of vector. So from the origin point of here, O or 0, 0, 0, so direction of cosine of vector. Okay, this is the we call an angle from the x-axis to the vectors of O to A, and beta represent the angle between the y-axis with the vectors of OA, and here gamma represent the angle between the z-axis with the line of O to A. Okay. So vectors of A, OA, as you see is here now, AI plus A2J plus A3K. If A makes an angle of alpha, beta, and gamma with a positive direction of x, y, and z axis respectively, then so cos alpha equal to the magnitude of A1, which is I, divided by the distance or absolute values of the vectors of A, cos beta and cos gamma, as you see 3 here now. So direction angles of vector of A, alpha equal to cos of A, we call magnitude of I, A1 divided by the modulus of A, also with B, and also and here for gamma. Okay. And note that cos square alpha, okay, cos square alpha here plus cos square beta and cos square gamma equal to 1. Okay, there is a given example here. If A equal to the vectors of A equal to negative 4i plus 2j plus k, and vectors of B given then negative 3i plus j plus k, so find the absolute values of A, the vectors of A, and the unit vector of A. Okay, so let's continue. Okay, I rewrite or write again the both of vectors of A and B when vectors of A equal to negative 4i plus 2j plus k, and the vectors of B equal to 3i minus 3j plus k. Okay. So then, the first question given then, find the this one here, which means that we are going to come up with this formula of negative 4 square plus 2 square plus 1. Sorry. Okay, 1 square. Okay, so come up here now. Square of 4 equal negative 4 square equal to 16 plus 2 square equal to 4 plus 1 square equal to 1. 16 plus 4 is 20 plus 1, then you come up with square root of 21. Okay, so then the unit vector of A, okay, equal to the vectors of A divided by absolute values or distance of the vectors of A, which is negative 4i plus 2j plus with k divided by square root of 21. Okay, so then we list down here one by one. It is negative 4 divided by square root of 21i plus 2 divided by square root of 21j plus with 1 over square root of 21k. Okay, then for question B, please refer to the, we call the lecture notes then, the direction cosine and direction angle of vector of A. So then direction cosine So direction cosine of vectors of A, which is cos alpha equal to, okay, direction cosine for each of these cos alpha equal to negative 4 divided by square root of 21. Okay, cos beta equal to 2 divided by square root of 21, and cos gamma equal to 1 divided by square root of 21. Okay, so now the direction angle of the vector of A okay, so which is negative 4i plus 2j plus k is given then. Okay, actually that we get it all the answers from here. Okay, look at the first one here now. From cos alpha equal to negative 4 divided by square root of 21, then alpha equal to arc cos of negative 4 divided by square root of 21. Okay, so if I manage to find the answers using the calculator here, press the button of shift and cos and it gives you arc cos. Okay, and then set up, recall the calculation then. It is negative 4 okay, divided by square root of 21. Okay, as you see string here now, then press the enter button here. Okay, so it gives me 150.8 degree. Okay, so now this is for alpha. So what about the rest of them? Okay, I'm gonna clear this class. Never mind. I think that I'm gonna solve all this in your examination. Please write it properly, and the answers recall in one page, and then if the page is full, please go to another page. For these lectures, I just write down all here, not to recall, wasting so much time here. Okay, now look at this one here. Cos beta equal to 2 over square root of 21. So then beta equal to arc cos of 2 divided by square root of 21. Okay, so press the button at cos here. Press the button of shift and cos. It gives you a cos. Okay, and then setting up we call the formula inside, which is according to that one is 2 divided by square root of 21. Okay, as you see the screen here now. Okay, and press the button equal. What you see in the screen here now? It gives us 64.1. Okay, so you may repeat the process to find that we call the value angle of gamma here, and I straightly give you the value of this gamma equal to 77.4 degree. Okay, so we get three values of angle, direction angle of vectors of alpha, vectors of A here. Okay. Okay. Oh, okay. We reach the conclusion, which I think that you almost at the end of the we call at the end of the lecture here now. Okay, so I'm not gonna look at this formula before. Wait a minute, which I think that I'm only answering question of A and B only, right? A, B, and wait a minute. I only answered the question of A and this one here, and also question of B. So I forgot to continue with the question of C. Okay, never mind. Again, rewrite the vectors of A equal to negative 4i plus 2j plus k, and the vectors of B. Okay, sorry, it's the vectors of B then here. Vectors of B equal to 3i minus 3j plus k. So question C is find the vectors of A plus with B. So look at this one here now. Magnitude of I with negative 4 plus 3i plus with magnitude of j, which is 2, plus negative 3j, sorry, plus with k, 1k and 1k. K 1 plus 1, 4k here. So negative 4 plus 3 equal to negative I. 2 plus negative 3. So 2 minus 3 equal to negative 1. J, and 1 plus 1 equal to 2k. And the next question is 2a minus 3b. So 2 times the vectors of A, negative 4i plus 2j plus k, minus 3 times the vectors of B, 3i minus 3j plus k. Okay, so multiply k, the constant of k, with every single magnitude here. 2 times negative 4, negative 8i plus 4j plus 2k, and then minus 3i. 3 times 3 equal to 9i, negative 3, negative positive 9j minus 3k. So negative 8 minus 9, negative 17i. 4 plus 9 equal to 13j, and 2 minus 3 equal to negative k. Okay, there you go. Okay, so we go the sign of the vectors there. Okay, the conclusion, as you've seen here now, the magnitude and unit vector direction of a cosine here. So there's an exercise for you to try. Okay, so what if I give you all the final answers of this? For we call the vectors of AB. Okay, we mentioned the position vectors of A, points A and B. So it means that this is the vectors of OA, and this is the vectors of vectors of OB. Okay. So this one with, if I give you with AB here, try to find out by yourself. It's gonna give you negative I minus 3j plus 4k. Okay, the distance or absolute values of vectors of AB, and this one gonna give you square root of 26, and the unit vectors of AB, and here okay, which I think that negative 1 over square root of 26, negative 3 divided by square root of the 26, and 4 divided by square root of 26. Okay, and then see the direction vector from the unit vector of AB one by one that I mentioned to all of you just now. Negative 1 over 26, negative 3 over square root of 26, and 4 divided by square root of 26. Then find that alpha, beta, and gamma. The same process that I showed you just now in the example 1. And position vector of point P which divide AB in the ratio of 1, 2. Okay, for this one, it give you find the position vector of point P which divide AB in the ratio of 1, 2. So that OP, okay, the vectors of OP equal to nope. It is 1 over 3. Then we call the vectors of magnitude of I, J, and K. It is 8i plus 3j and 1k. So please try to get answers of all this, okay, by yourself. Okay, so class, this note made by one of my colleague, Mr. Rodi, okay, and he was the first in my unit that with his initiative and efforts to bring up all the videos of what we call explanation of finding the solution of the maths subject. And as you see here now is all the videos referring to the subject topic of vectors. So you may refer to his videos, and I do hope that his videos really helps you a lot to understand the content of the topic of vectors in this syllabus. Okay, and also the list of the video playlists that you can find it by yourself. And that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.